So here's 5A from the 2014 AB exam, and in this question, they provide us with a table with all sorts of values of functions and their derivatives, and then the sign of functions and derivatives on certain intervals. They tell us that f and g are twice differentiable, and then the values up here represent f, f prime, g, and g prime. And in part A, we want to figure out where the x-coordinate of each relative minimum on the graph of f is going to occur for the x's between -2 and 3, and then justify your answer. So basically what they've done for us in this chart is they've constructed a sign chart for f prime for us. It just looks like it's in a different notation than we're used to seeing it in. If we wanted to do a sign chart for f prime of x, which is what you'd hopefully think to do if you're looking for a relative minimum on f, you'd build a sign chart for f prime. You'd have to figure out where f prime is equal to 0. Well, that's told to you. It says f prime is equal to 0 at, based on this number, at -1. So we'd have to have -1 as a place where the sign of f prime could potentially change. And then f prime is equal to 0 again at +1. And so f prime could potentially change signs as we go across the x value of -1 and across the x value of 1. We do have to figure out if f prime is ever undefined on this interval. Well, since the function is twice differentiable, the first derivative exists everywhere and the second derivative exists everywhere. So we don't have to worry about that at all. So what we would want to do is we'd want to say, all right, what's the sign of f prime to the left of -1? Well, they flat out tell us that. In between this x value, -2, and this x value, -1, the sign of f prime is negative. Between -1 and 1, the sign of f prime is still negative, and then between 1 and 3, the sign of f prime is always positive. So that means our function f is decreasing on this interval, decreasing on this interval, and then increasing on this interval. Where do you have a relative min? Well, you have a relative minimum as you cross this x value of 1. So you do have a relative minimum at the x value of 1. Now the work that I have on this screen will not get me the justification point to justify my answer. What I'd have to write on my page, which I'm not going to write out, I'm just going to state verbally, is since f is decreasing to the left of 1 and increasing to the right of 1, we have a relative minimum at x equals 1.